So hi, I'm Don. As he mentioned, I'm from Screen. We're super interested in web application security. And today I want to talk to you about, in particular, Rails web application security, things that you can do as you're scaling up your web application and maybe a startup even around that web application to ensure that it's secure. I want to talk a little bit about why you should care. And at the end of this, we're actually going to try to hack into a website that I've got running up here. Not try, we're going to succeed. It's going to be fun. And you're going to learn all sorts of crazy things. So the first question I want to ask is, like, why do we even care about security? I love this. Is this going to play? No, it's not going to play until I do that. Is it going to play now? Yeah, there we go. Right, like, there's so much that we can do to secure our web applications that's effective, and then there's like security theater. There are things that we can do that make us feel good about what we've done, like, I don't know, put a digicode on our fence, but that don't actually do anything to secure our web applications. And I want to spend a little time thinking about like the difference between these two things. But the first question I want to ask is, why care in the first place about security? It's not a rhetorical question. I'm looking for answers. Tell me. Anyone? I'm sorry? Because not everyone is nice. Because not everyone is nice. That is unfortunately true. Customer data privacy, yes. I think we're getting closer. Because we care about our users. Oh, I love this answer, right? If we're building a web application, we're not doing it for ourselves, unless you're me. I only build web applications for myself because I need something and then I don't distribute it. Most of you are building web applications because you want other people to use them. All right. By the way, I'm very excited. I'm American. It means I'm going to speed up and talk really fast. If something moves too fast, just let me know and I'll slow down. Okay, I promise. So we care about our users. We want people to actually come and use our web application. Now, right now, we live in a really nice time in which the default for web applications that live in the cloud is that we should trust them. It's okay, let's give it a shot, we'll see what happens, right? This wasn't true 10 years ago, right? 10 years ago, people thought about web applications and their reaction was, why should I trust this? This is nuts, I have no control over any of this, it's in the cloud. Why should I trust these randos on the internet with my data? Today the default is, well, of course I should trust them until they prove otherwise. We do security because we don't want to prove otherwise. We want people to continue to trust our service. We want people to continue to use our service, right? And so we do security because we want our users to feel like this is something they can trust, that they can give us our data, and it's okay. So, to that end, you might ask yourself, well, okay, but nobody knows about me, right? Like, fine, I believe in my users, I believe that I should gain my users' trust, but in the end, nobody's paying attention to me. I'm small fry, right? Well, our data scientist told me, like just last week, this very interesting thing. He did a little digging in our data, and he asked me, like, what is the mean time between one of our customers launching on Product Hunt and the first attack? What do you suppose that is, if you had to guess? Like, what is the mean time between a Product Hunt launch and your first real attack? Anybody?
6 months.
6 months. A week?
5 minutes.
5 minutes? Wow, we're all over the place here. I'll give you a hint. It's 2 seconds? Days? Minutes? 2 hours. 2 hours between you announcing to the world, hey, I've got this cool thing, and somebody else figuring out, hey, I can break into this cool thing. Like, okay, 5 minutes, that's but 2 hours, that's terrifying, right? No, I don't say this to scare you, but just to give you a sense of one thing that many early stage startups do is they say, oh, this can't happen to me, I'm too small, right? I've heard that many times myself, and the answer is no, you're not too small. if you just launched on Product Hunt, if you have even a modest user base, like you're a reasonable target. So we want to take security very seriously because we care about our users, right? We care about our users coming back to our product. We care about our users recommending our product to other people. And so in that light, I want to suggest that because hierarchies of needs are very popular things in San Francisco right now, let's talk about the hierarchy of security needs. And at the very top of that are users, right? So when users use our application, what are they doing with it? What are they giving us? What is it that they're trusting us with? You're sharp. Data, right? And so protecting our users means protecting users' data, right? How do users access this data, provide that data to us? It's through our application, right? That's the primary mode that they're interfacing with us, right? The application that we build is far and away, I mean, it's designed explicitly to be a window for providing data to us and processing that and providing data back to them, right? So it is the largest security issue, right? Because it's a product designed explicitly for manipulating this data. Right? Our application exists on a network. We're building cloud applications, SaaS applications, right? And so the next biggest window after the application is the network layer itself. So if people can intercept things on the network layer, then they can maybe bypass the application itself. And what sits underneath that is the physical layer, right? If people gain access to the servers, for example, that host this data, then they can bypass the rest of this. So the idea here is with this hierarchy, the users are at the top of it. That's what we want to protect the most. We protect our users by protecting their data, right? The gateway to the data is the application. The application exists on our network. The network is ultimately subsisting upon a physical layer. And so if we can think about our security needs in terms of this sort of hierarchy, we can begin to prioritize what it is that we need to do to build a secure application. Because ultimately the goal here is not to do everything all at once. We can't do everything all at once. Like, I expect that one of the lessons that you learned here at 42 when you're building an application is to begin with a minimum viable product, right? It's the same thing with security. You can't jump all into it all at once. That's ridiculous. Nobody can do that. Nobody will succeed if they do that. You want to begin with minimum viable security. And to understand what minimum viable security looks like, the idea is to think about it in this kind of framework here, right? To assess, like, how do we protect the user? How do we protect the data? How do we protect the application, the network, and the physical layer? And what can we do right now that's going to have maximum impact on this kind of thing, and what can we defer to later? And so what I want to talk about from this point forward is, what are things you can do right now? What are very easy steps that you can take with your application that will ensure like a very solid foundation moving forward, right? Because we don't want to do it all at once. So let's start with the physical layer. Secure your laptops. Right. How many of you have lost a laptop? Yeah, a few of us have, right? Actually, I haven't. I'm putting my hand up anyway, because I know people who've lost their laptops, right? They put it in that little pocket on an airplane, you know, in the seat in front of them. They get off the airplane, they forgot to take it with them. And there's a lot of secrets on your laptop, right? That if somebody can get physical access to your laptop, even with hard drive encryption, eventually they can crack these secrets. So the very first thing is secure your laptops, right? So at Screen, we have this policy, for example, if you leave your laptop open and unlocked, I imagine there's a lot of Slack users in the room, random people will see that and go, oh, look, this guy just left his laptop on top. We'll just go into general on Slack and promise everybody cookies. And then the next day cookies arrive and it's fantastic, except for that person who had to actually go and buy them because they left their laptop open, right? So that's a nice little hack for dealing with laptop physical security. The same thing goes if you're working in a coffee shop, you're working on an airplane, right? Don't leave your laptop open. Right? It should go beyond saying, but Back up everything and then back up the backups and make sure the backups work. So who here remembers a company from the United States from the late 90s, early noughts called Danger? Oh, it's a pity. Danger was the precursor to Android, right? What was Danger? All the engineers left, they joined Google, they built this thing called Android, it was fantastic. But the reason that this happened is that, in the late 90s, Danger had the first smartphone. And everything was in the cloud. A completely radical concept in 1999, right? So you buy this phone called a hip top, and you could communicate with other people. It had email support, it had a web browser, and it kept all of your data in the cloud, and it was very cool. It was so cool that Microsoft went and bought them, right? So Microsoft bought Danger, and like 6 months afterwards, somebody managed to kill the production database. As you do, right? Well, no big deal, we'll just restore from a backup. Backup didn't work. Okay, fine, the backup of the backup, we'll revert to that, it's fine. That's missing, right? 6 months later, they'd managed to piece together from various different places across their infrastructure, approximately 60% of the data that customers had. But by then the damage was done. It was too late because everything was stored in the cloud. Customers lost access to their data. It was game over for Danger and Microsoft, at which point all of the engineers had left and gone and joined Google to build Android instead. So in some sense, it's not so bad. But what happened here is even large companies have terrible backup regimes, right? So make sure you have a good backup regime going so you don't end up in this sort of place because your customers are basically just going to leave you if you don't. Of course, about the physical layer, we have the network layer. So don't use public Wi-Fi. And if you have to use public Wi-Fi, use a VPN. I'm going to make a lot of references to the last couple of episodes of the most recent season of Silicon Valley. Who here has watched Silicon Valley? Who here has not watched Silicon Valley? You should totally watch this show. It's great. In the last couple of seasons, the last couple of episodes of the last season, they highlight the dangers of connecting to a public Wi-Fi network. And the danger is that basically everybody can listen in to what you're doing. And they can even listen in under certain circumstances over encrypted connections, right, over HTTPS. Don't do this. Don't connect to your Amazon AWS account to do administration work over a public Wi-Fi. It's just a bad idea. Use a VPN instead. So for example, if you're on Mac, TunnelBear is a really good alternative to this. It's free up to a certain amount anyway of bandwidth, and it integrates very nicely with the operating system. Windows people, I don't have a good solution for you off the top of my head. But those public Wi-Fi hotspots are actually quite dangerous. And when you do connect to a service, do try to make sure that you're connecting to the secured connection version of the service. A surprising number of services that you may use offer the opportunity to connect over an unencrypted connection. And when you do that, then it's absolutely no problem for anybody who's connected to your network to just listen in on what you're doing. And for your own product, right? We want to do this as well. There's no excuse not to offer TLS, secure HTTP, for your product. Cloudflare and Let's Encrypt are two free products that you can use to ensure that your customers are connecting to your own service in an encrypted fashion. So now let's talk about the application layer. This is where things begin to get a little more technical and a little more interesting. So first of all, monitor your dependencies. So by and large, everybody here is building with Rails? Yes? Is anybody not building with Rails? What are you building with? I'm sorry? Python and Java, okay. So it's the same story with Python and Java, it's just not called gems, they're called something else. They're Python modules and Java, actually I don't know what they're called in Java land, but the idea is you know, when you're building on Rails or when you're building on Node, there's this tremendously powerful ecosystem of third-party dependencies that we've become accustomed to using, right? And it's cool, it's really cool. We can tap into the collective knowledge of other people and leverage their work to make our product even more awesome, right? But sometimes vulnerabilities are found in these. It's not surprising, right? They're often fixed quite frequently, but you should keep on top of this, right? Because a vulnerability in a dependency that you rely on is now a vulnerability in your own code. And if you're not monitoring your dependencies, then you don't know that there's not a vulnerability in your own code. So GitHub just launched a new project. I imagine many of you in the room are using GitHub that will look at your Ruby dependencies and tell you when you've got something out of date, right? It's a free service that GitHub is offering. Take advantage of it. If you're a screen customer, we do this too. That's great too, right? But actually, the GitHub offering is pretty freaking good. Like, use it. Avoid unsafe templating methods. So this is one we're going to touch on in the demo, right? So how many people are using Active Record with their Rails apps? Active Record is a pretty cool ORM. ORMs are good. ORMs will, in general, help you ensure that you're not doing things that are unsafe. ORMs will also let you shoot yourself in the foot, and I'm going to show you how you can shoot yourself in the foot a little later on. I really want to emphasize this one because it's how do I put it? Now, I'll let the demo speak for itself in a moment, right? And security headers at the same time, right? So how many people are aware even of the concept of a security header? How about an HTTP response header, broadly speaking? Okay. This really, like, there's a lot of there's one exclamation mark up there, and there's a whole lot of capital letters. This is really worth bearing upon. So an HTTP response header is basically an instruction from your web server to the web browser that's connecting to it that says, hey, I need you to behave in a very particular way. Override your default behavior, and let's talk seriously for a moment. I need you to be secure, right? And in general, I've had to change this slide recently. In general, like, Rails by default emits a number of security headers automatically that are very good, right? They tell your browser to be smart from a security perspective. And I just recently discovered, as in like yesterday, that that's not good enough, right? So it turns out, for example, Firefox, which was kind of a minor player until this week, was not really listening to a lot of these security headers. And you might think, it's Firefox, whatever. Except that Firefox 57 is really, really cool, and it's caught on fire, and even I'm using it now. And it's not paying attention to these things that Rails are saying that it ought to pay attention to. Do not rely on the Rails defaults for these, and I'm going to talk a little bit more in some detail about what a good security header or what a good collection of security headers means. But if you're not sure, there's a couple options that you can use. The secure headers gem is a really, really good start at just applying some default security headers to your Rails application that go beyond what Rails provides. It's also very configurable. And if you don't feel comfortable with that sort of configuration, I'm going to pitch screen again. We'll inject those headers on your behalf as well and offer a mechanism for configuring them. This is something we're going to revisit in the demo here in just a moment too. Use safe ORM calls. That's kind of overlaps with avoid unsafe templating methods. So I'm going to skip that for now. And then use a real-time security monitoring and protection tool. So we just recently performed a survey of Node developers, and I realize Node developers are not real developers, and there's quite a difference. And something like 70% of Node developers had no idea if they were under attack. Like, that's terrifying. Like, it's one thing to say, oh, I write very secure code and I'm too small to be under attack and make these claims. If you want to make these claims, back them up with data, right? employ a monitoring solution, of which Screen happens to be one of them, but there are other monitoring solutions out there as well, of course, to understand exactly what the threat looks like. Right? If you don't know that you're under attack, this is actually going to be a problem under the new rules called, and I can never get that right, GPRS, GRPS? Can somebody? GDPR? Oh my God, it's even the wrong letters, not even the wrong order. GDPR, right? So the new GDPR rules that are coming out require you to not only know that you're under attack, but then report it to an EU agency in a timely manner. That you have experienced an attack that has resulted in a data breach. This does not mean that you have to acknowledge it publicly, you just have to acknowledge it to this EU Commission, right? And then on top of that, you have to be able to talk about the kind of data that has been breached, but that's an issue for a different slide. So know if you're under attack, find a way to know if you're under attack, and then you can talk intelligently to your customers and to the government agencies that you interact with. All right, so gift break. I like googly eyes. Let's just take a breather for a moment and think, okay, that was a lot to ingest. So finally, we're working our way up the pyramid. Let's talk about the data that you have to protect. Building a web application. So there's a theme you're going to see here, which is like, don't trust anything your users give you, because your users are up to no good. Because what was it you said?
People aren't nice.
No, people aren't nice. In fact, they're pretty freaking horrible. They're awful. And they're going to do awful things to you. So does anybody know the XKCD comic strip about little Bobby Tables? Yeah, it's a classic. Oh, it's so funny. Oh, yeah, except they're going to try that immediately, right? Two hours of the product hunt launch, and Little Bobby Tables is going to be signing up to your service. Only it's not always Little Bobby Tables. Sometimes it's Little Bobby rm-rf/. Right, so if you have any kind of endpoint that exposes Unix commands or shell commands, these are ripe for exploitation. And so if you need to mix those with user data for whatever reason, there are probably legitimate reasons for doing that. Just remember, sanitize that data. I'll show you an example of this in the demo too. You know, why not? Let's just make this a general rule. Do this for all user data that you get. For good reasons that, yeah, we'll save this for the demo. And keep secrets away from code. So your application needs to connect to a number of other services, almost certainly, right? And those services are going to require secret API keys. Don't put those in your code, right? So I used to work for Slack, and about 2 years ago, the Slack security team decided to do an audit of GitHub to see if they could find any Slack authentication tokens on GitHub. Slack authentication tokens are very distinct. They begin with XOX, a letter, a dash, and then some other stuff, right? So they're very easy to search for on GitHub. And they thought, well, we'll probably find a few. Guess how many they found? Thousands? Maybe tens of thousands? Tens of thousands, many of which were literal keys to the kingdom, right? People had hard-coded these things into their applications and then committed them into GitHub, right? Slack is one thing. AWS keys, on the other hand, are another thing entirely. And there are entire bots out there that do nothing but troll GitHub each day looking for AWS keys to break into your AWS account, right? It only takes one momentary lapse before somebody finds that stuff. So there are a lot of good services for this. AWS Parameter Store, HashiCorp Vault, environment variables are a viable option here. Do you have a question? Yeah, no, it's fine, right? Well, at least from this perspective, if you put it in an environment variable, it's not your code, it's not getting committed to GitHub. Sounds good to me. There are other ways for people to get in your environment variables through Actually, I don't have that in here, but they can get your environment variables through vulnerable dependencies. So one thing I haven't mentioned here, since you bring this up, I'm just going to talk about it very briefly. Did anybody follow the typo squatting dependencies on NPM about 2 months ago? Okay, so this is a problem for Rails, or a problem for Ruby generally, although it hasn't come up in Ruby land yet. It's come up in Python, it's come up in Node, where a developer will take a well-known package that's kind of difficult to spell, create a package that wraps the existing package, publish it under a common typo for that package name. And so if you mistype the package name in your dependency list, you pull it down, everything seems to work okay, except there's one small addition, which is the exfiltration of environment variables to somebody else's server. So that happened for about 2 days on NPM, on Node, about 2 months ago, right? So that's one reason to be suspicious of environment variables. But for the most part, like, that's fine, really, it's fine.
They overrate to not some of the code, they're almost viable. Where could you put a system?
So I'm a big fan of HashiCorp Vault. It's a tool designed explicitly for this. The secrets exist only within this vault. And the way that you access it is secure in such a way that no third-party project can intercept this. I have to admit, it's a little bit of magic. I don't fully understand exactly how it works, but these are a far sight better than environment variables. Nevertheless, even environment variables are a huge step forward from hard coding them in your code, right? I mean, because the emphasis here is like easy things you can do now, right? So finally, then there's the user themselves. Users are finicky things, they're people, right? So, for example, encourage, but do not require strong passwords, right? In the same token, encourage, but do not require password lengths. So what was I signing up for today? I signed up for something today, I can't remember. I use 1Password to manage my passwords for me, and by default I've got all the sliders all the way out to the right, and it said, you can't use a password more than 32 characters long. Really? Like, why is this? And storage is cheap. There's no reason for this. Don't do crazy things that make people jump through hoops just to sign up to your service, right? Don't disable copying and pasting of passwords because that disables password managers, for example, right? But at the same time, don't demand that they include exactly 1_, 3 numerical characters and a close parenthesis, right? Because then they're just going to get mad and not use your service. You remember, the goal here is to build user trust. They're not going to trust you if they're not using your service. And if they aren't using a strong password, maybe that's their own problem. Do hash the passwords. Is there anybody here? No, I shouldn't ask that question. Everybody here is hashing passwords, right? If you're not hashing passwords, just nod along and pretend that you are. I worked for a startup once that was not hashing passwords because it was inconvenient, it slowed down the login process, right? But that's exactly what hashes are designed to do. They're designed to slow down the login process for people attempting a brute force attack, right? The more costly a brute force attack is, the less likely it is to succeed, which means, necessarily, it's going to slow things down for users. About this much. Hash them. And add a salt. If you don't know what that means, we can talk afterwards. And then use a real-time user monitoring tool. Once again, last time, I promise, I'm going to plug Screen, right? Screen is a tool. There are other tools out there as well that can monitor whether or not people are trying to break into user accounts, whether or not they're performing an account discovery attack, right? Where they got a database from somewhere else, and they're trying to see if the passwords and usernames that they have will work against your site, right? There are lots of great tools out there, including Screen, that help you protect your users proactively. So, next up, the live demo. Matthew.
Back to the passwords, do you recommend using a library like Devise?
Yes, actually for Rails, I strongly recommend Devise. Devise is time-tested, it's effective, it's easy to install and configure. Like, Actually, that's really good advice for everybody in the room using Rails. Please use Devise. Devise is great. If you're not building on Rails, well, actually, I don't know what to suggest for Python. I'm going to be completely honest. Or Java, for that matter. But for Rails, I can recommend Devise. One more time, I'm sorry? Right. Yeah. So you said the password hashing is usually encapsulated by one of the authentication packages, right? And Devise does the same thing on Rails, right? So if you're using Devise, like, you get this automatically. It's great. So, deep breath. Is this going to work? Let's find out. So what we've got is, which way does this need to go to? Oh, hello. Nope, we're not ready. Okay. I'm a JetBrains fan. I apologize to those of you who are not used to JetBrains. We're going to be using it today. We've got a web application that we call Web Cows. For some reason, it's got nothing to do with cows at all. In fact, it has everything to do with, Star Wars characters, hello. It's a very simple application built in Rails. It's very straightforward, right? It has some Star Wars characters. You can add new characters, you can comment on the existing characters, you can rate your favorite characters. It's very straightforward. It's also got issues. Let's begin. So, the first thing that any kind of attacker worth their salt is going to do is they're going to see that search field right there, right? And they're going to think, can I exploit that? And they're going to do this. They're going to take a little, I don't know if we're going to be able to see it here very well, a little snippet of HTML. It looks like that, except you can't see all of that very well. So the idea here is we're going to attempt a cross-site scripting attack. We're going to inject a script into this field and see if we can get that script to execute. So the idea here is maybe when we do a search in this field, it's going to get reflected back. As a matter of fact, let's just put in hello and see what happens, right? So when we search for hello, well, the search is a little broken because we haven't implemented it. It's okay, right? But the hello stays in that box, right? And you can see it in the query parameter up there, right? So this looks like a prime target for a cross-site scripting attack. And the idea here is if we can get it to render a little bit of HTML on our behalf, we can inject a script tag, right? And inside that script tag, we can run a little script. Right? And so what I have is just a very basic alert dialog that we're going to run as a result of this. Right? And let's see what happens. Oh, yeah, see, there's a problem. Our alert dialog has been run, right? So this thing is actually not escaping the user input. It's just getting injected directly into the HTML of the page. Since our HTML included a script tag, then the code within the script tag is getting executed. In this case, it's just an alert that opens a dialog. I mean, you can even see it there in the URL bar, right? It's just an alert that says, "Oh no, pwned," because that's what happened. Well, that doesn't seem so bad, right? But this is just testing. If we can inject this into a page, it means we can inject anything into the page, right? We can get user credentials, we can alter the view of the page. We have complete and total control over the front end. So this is what's called a reflected cross-site scripting attack. The idea is that you put in a little JavaScript, you get a little JavaScript out. So an attacker, once they discover something like this, they'll take that URL up at the top, they'll send it to some unwitting person who then clicks on the link, and the script gets executed automatically. And probably what it does is it finds their credentials and then sends them off to a server somewhere where they can be collected. And that's pretty terrible, right? So if we go back to our code, we can see exactly where this happened. So, wow, I don't know exactly how it chose to open these files because these were not the ones I had open in advance. Anyway, the vulnerability is in our template file for the front page, and it is in fact on line 12. Where's line 12? Right, so here's the line of text or the line of HTML for the search bar, and right here is where we're showing the previous search query to have it show up inside of the search bar, which is a very handy feature, right? You want people to see what they've been searching for, and it's fine, it makes sense. But for whatever reason, stupid Don has put that raw there. Does anybody know what that raw means? Yeah, it means don't bother escaping it, right? There's another syntax for this which is more common, or sorry, less common, but easier to accidentally do. This does exactly the same thing, right? % equals equals. It's easy to type the same character twice in a row. And what happens basically is it says whatever the user typed in for that parameter, it's fine, just put it there unescaped. That's terrible. So if you just leave it as a % equals, everything's good. Because what Rails then does is it sees that first greater than symbol, and rather than treating it as a little bit of HTML that closes the previous tag, it renders it as ampersand GT semicolon, right, which is completely innocuous. And that's fine. Now, one thing I want to point out, I'm going to put this back in. I'm not going to bother closing that out, is this. Hey, look, it's terminal. If I do curl, let's look at the headers that are coming through. So I said I was going to talk a little bit about headers. There we go. Let's just go back up here to the top. Here, right here. These are the headers that our application is emitting by default. We don't care about most of them, but we do care about, for example, this one. So this is a really cool header. This is something that Rails emits by default, and it tells most browsers, don't allow that kind of shit to happen that I just demoed for you, right? It says to the browser, look, if you see some embedded JavaScript, it's not supposed to be there. Do not execute it, right? Except, 1, that header is there. 2, that script got executed anyway. 3, it was in Firefox. 4, Firefox does not support this header, which is a small thing, except that 5, Firefox is on fire. Do not rely on the Rails defaults to protect your ass. That was great advice 2 weeks ago. This week, that advice no longer works. Why? Because this header is technically deprecated, and Firefox is expecting to see a more modern version of this header called the Content Security Policy, which I'll come to in just a moment, which Rails does not emit by default, except in the most recent version, it attempts to construct a CSP for you. If you're running an older version of Rails, do not count on this. It's not going to work. So, make sure it looks like that. We'll just rerun that. When we do that, yep, it's running. And when we hit refresh, yeah, no pop-up. We're good, right? Because Rails has actually escaped that in the background. That script actually doesn't show up as HTML that's been injected into your web page. Everything's good. Okay, so that's reflected XSS. Let's talk about stored XSS. This is the same kind of attack, right? We're going to attempt to inject JavaScript into this page in a way that tricks the browser into executing it, but we're going to use a slightly different mechanism, right? Instead of putting it in a query parameter where it gets rendered into the template, we're going to actually put this in the database. So let me just get that up. So we've got this great little thing here where you can add your own character, and look, oh no, it's another form. That should be highly suspicious. And we're going to enter a new character into this database. What's your favorite Star Wars character? Anyone? Darth Vader? Oh, come on, he's already in the database. You saw him on the front page. Pick a different one. Be more creative. Yoda? All right, so we're going to call this guy Yoda. Not really. We're going to call him the script injection. And we're going to create a character. Oh, and sure enough, here we are back here. This one's actually worse, right? So in the previous case, we had crafted an attack that appears in the URL. You had to send the URL to somebody, and they had to click on the URL in order to initiate the attack. The problem is, now we've got an attack that's stored in the database right here, and anytime somebody goes to see details, so it's basically everybody. It's not just somebody you emailed it to, it's everybody who comes to the site. So that's what a stored cross-site scripting attack looks like. It's basically the same sort of thing, but it gets stored in the database, so it gets presented to everybody. And again, it's actually quite easy to find where this is. It's in, it's in the template for showing an individual character on line 26. There's another one of these instances of raw here, right? Or again, it might look like that, which is super easy to accidentally type and not so super easy to visually grep for. And we'll just save that and we'll rerun it. And again, in most cases, you would actually be protected by that header, except Firefox and the fact that the header is deprecated. But now, when we come back to the site, having changed that, everything's good. Now he's just got a funny name, and you're wondering who is the jackass who typed this in. Right. All right. So far, this seems pretty low key. Right? Not a big deal. Okay, so they inject a little script, they popped open a window, maybe they pwned one of our users. There's something more terrifying waiting for us here. So let's go back here. Now let's just look at one of our characters. We like Darth Vader apparently, so let's look at Darth Vader. And let's look for a brief moment about the construction of this URL, right? So it's really straightforward. We have a character model somewhere in our Rails app, right? The characters each have an identifier that's a number that we use to pull the character up. It looks like Darth Vader's number 2, right? So somewhere in here we've got an SQL query that's doing a select star from characters where ID is 2, right? Right? Okay. This seems ripe for exploitation. Is anybody here familiar with a tool called SQL Map? No? This should scare the snot out of you. Let's just clear this. I happen to have it installed on here. It's a cool tool that can tell you if you have an SQL injection exploit available, right? And if there is an exploit available, it can do all sorts of interesting things. Oh my goodness, there's all the tables in our database. It gets worse. This is so much fun, it's ridiculous. It will even give us an SQL shell. Oh, look at this. I don't know, select star from users, what? Oh, shit. What's that? It's the password hash in their login. All from that URL with an unescaped bit of thing in there. This is really fun. You can run this against a whole lot of sites and basically gain access to their entire database. It's absolutely freaking ridiculous. I don't recommend you actually do that. I'm pretty sure that they'd throw me in jail if I actually recommended you do that. So don't, please. Except that So here's what's happening that's led us to this terrible situation on line 79 here, right, where we've got our cow constructor, our character constructor. We call an active record find by SQL, and we pass in, so select star from cows where ID equals, and that parameter, right? The parameter is what appears in the URL, right? So it's characters/2. So we just pull 2 off of that, pass that in here, right? Select star. Ignore the fact that we're conflating cows with Star Wars characters, please, for a moment. I didn't write this code myself. So we're looking for character ID 2, find that pulls Darth Vader out of the database, it displays it in the database, that's great. But what if we passed in something other than 2? What if we pass in something that looks like this? Right? So what we have here is character 1, union. Are people familiar with SQL? Vaguely, right? Union, select all these other fields from the users table, right? What it actually does is it populates the character schema with the data that it extracted from the users table, right? So here's our admin user right here. SQL Map is smart enough to understand how these sorts of things work, right? It will attempt all kinds of things like this. Look at the output on the web page, look for subtle differences depending on how it alters that structure, right? And it figures out very quickly that it has full access to the entire database. And it gives you access to the database through manipulating URLs that look a lot like that. And it's absolutely nutters. The good news is, it's pretty easy to remediate. Don't ever call find by SQL. Just don't do it. Right? So the solution then is to do this. Right? The ORM provides us with a very handy method called .where, and then we can provide the ID. And then if we want to be extra special paranoid, which we do, because we know the ID is a number, we can just tack 2i on it, right? And it's going to see the 1 space union, and it's going to throw everything away after that space. It'll just be 1 after that, and everything is nice and cool. Don't trust this completely, however, because Active Record does have known vulnerabilities. So for example, the exists method is very, very good at sanitizing strings that get passed to it. So this method can tell you, does this record exist, right? But if you pass it an array, it doesn't bother sanitizing the array. And so if you pass it an array of strings, and these strings are ugly, shall we say, it will go ahead and execute those without sanitizing them, right? So be very careful about the data that you receive from users. Do not treat it as something that you can trust. Basically, don't. It's ironic, right? We want our users to trust us, but we can't trust our users to send us good things. All right, so I'm going to put things back where they were, back in their ugly, ugly, ugly state, where everything is very, very vulnerable. And I want to show you, of course, a very brief demo of screen. Oh, no. It's really hard to type when you're looking over your shoulder. So the idea behind screen is we can instrument all of these things for you. We can help you keep tabs on these things. Sorry, this is the product pitch part of the talk now. And we can help you mitigate against these sorts of issues, right? So here we are. Oh, I remember the other thing I need to do, sorry. Is I need to open the gem file. We have a gem. That's easy enough. Give it your API token. Nobody copy that down, please. It's my token, thank you. That would be most unfortunate. Oh, and we rerun it. We have to restart it. And Screen is tapping into the template rendering engine. It's tapping into the SQL engine to monitor the SQL queries that are being executed, to monitor the way the templates are getting rendered, and it's watching for things that are being injected that are inappropriate. So what happens now? Oh, here we are. So again, the code has been made vulnerable, just like it was when we started the day. And so theoretically, we should see, yeah, see, there you go. That's pretty cool, right? So even though Firefox is vulnerable, even though your code is vulnerable, even though we haven't taken any proactive steps beyond that, like Screen has jumped in and said, you know, that's not cool, right? And we'll do the same here. If we put that alert back in there, right, it's just not going to allow it to execute. And then here as well, right? If we attempt the SQL injection, like this is just going to fail, and you can see it here. If we attempt once more to try to do this with SQL Map, it just gives up, right? It's like I can't see anything. There are no SQL injections available to me. And Screen will generate a series of reports to help you understand, like, who's trying to mess with your app, right? And it will do so in such a way that it gives you, like, here's how the query got messed with, how the structure was changed, here's how it came in, and here's a line in your code where that vulnerability exists, so you can go back and remediate it so it doesn't happen in the future. All right, Screen pitch over. So that was a live demo. If you're interested in learning more about how to secure your Rails application, like I've got a whole table full of booklets over here. These booklets are not just an ad for Screen. They're a summary of the things that I've talked about. They actually run a lot deeper into many of the subjects that I've only just touched on today. The goal with these booklets, the Ruby Security Handbook, is to help you build secure Ruby applications. Our goal is to see a secure internet and to help you build that secure internet that we want to see. If you don't want a booklet, or even if you do want a booklet, you can even get it online at this URL. And that's what I got. You got this. Everything's going to be cool. We just got to think carefully about these things. Thank you.
If you have any questions.
Thank you very much. Just one question, because you started with the idea of the physical security. And to you, for a, let's just call a super admin computer, what is the right? You just said that encrypting the hard drive was not enough. What is the good behavior to handle that?
Okay, so to be clear, encrypting the hard drive is an amazingly good start. For example, however, when you boot up your Mac OS computer, I'm more familiar with Mac hard drive encryption than otherwise. Right? When you first boot it up, you have to type in your password, and guess what that password does? It unencrypts your hard drive, right? So if somebody gets your computer, even though you've encrypted the hard drive, if it's on, it's in an unencrypted state and they can gain access to it. So the most important thing is to maintain physical control over your computer at all times. / turn it off when there's a doubt as to whether you can maintain physical control over it. That would be the most obvious recommendation, I think. Is that helpful? It's something anyway, right? Don't lose your laptops. And if you're using two-factor authentication, how many people in here are in a position where you're using one of these things, like a YubiKey? Anybody in here? Yeah, for anything, like working for a company that's issued these. These are super cool. They're like, so two-factor authentication, except it's not your phone, it's this thing. You plug it in your computer and you touch it and it acts as a second factor. If you're not using them, the next point isn't going to be super valuable. But this thing is, as you can see, it's designed to sit inside of a USB port and just like stay there. In which case, it's not really doing its job as a second factor. It's just a first factor. But if none of you are using them, I don't have to admonish you to remove them when you're not using them. So it's kind of neat. YubiKey, Y-U-B-I-K-E-Y. They're super cool.
Just to be clear, the SQL map is using flows through the AT ports, right? It's not going through your normal database port, like the 9, 7, 800, and I don't know what's the form SQL Postgre. It's using your HTTP port.
Yeah, so the question was, to be clear, how is SQL Map attaching to the database? And it's purely through the web application. It is not connecting to the database server. That was actually SQLite, so there's no server. It's connecting through an SQL injection vulnerability in your application and using that as a conduit into the database directly. So when you have an injection vulnerability, like even the slightest vulnerability gives access to everything, tout le monde. Everything in the database. And tools like SQL Map. So to be fair, it was cached, the thing I was running there. In real life, it would take much longer to get those kinds of results, but much longer means 5 minutes instead of 10 seconds.
And if it's your production server, you don't even see it because it's just random requests on your log. So
Yeah, exactly. It appears as a bunch of perfectly normal, although somewhat odd-looking requests against your application. Yeah, lots and lots and lots of them, to be sure. Like, and you could probably detect it just by looking at your logs. If you thought you were under attack, you could spot it in your logs. The trick is knowing that you need to go to your logs to find it in the first place. But yeah, it's just normal accesses to the website.
do you have a screen? Do you have a premium type thing? Because I was one of your beta testers at the very beginning with only privatism. And I know that now it's quite expensive, but some of us have very small web apps and we can't pay a lot for what it's going to be.
I'm glad you asked. The question was, does Screen have a free tier? And the answer is, why, yes, we do. Yes, we very much have a free tier, especially for small projects and early stage startups. Yeah, I'm happy to talk to you about that afterwards.
Okay, a short question about Screen, the tool. Does it need to run live inside production code, or is it mostly a diagnostic tool?
So the question was...
What's the performance impact if it needs to run inside production?
So Screen itself is designed to run inside of your production code because it monitors the way that your users are interacting with your application in real time. And the idea is it's... I'm sorry? Well, no, it doesn't get uploaded to our servers, but it is analyzed in place by the Screen gem that's installed. So the idea is that it doesn't add any additional overhead, but it monitors it in line with your code to see if it's been modified, if the structure of the query has been modified by something that exists in the HTTP request. And if it's been modified, then it spools up a background thread to send a summary up to our servers so that you can get notified about it. Right. That's exactly right, in fact. About half of the SQL injections we detect were not intentional. They were triggered by users who used an unusual character or something like that. But that's actually good news, right? Because it means that we found an injection that was not triggered by somebody who was trying to break into your shit. It was triggered by an everyday normal user who had good intentions. It's actually a very good case, in fact, because it means you're not being threatened. But the fact remains, like, even in those cases, like, there is an injection there that could be exploited, and it's just a matter of time before somebody seeks something like SQL Map on that endpoint to find it. Yeah, so that's all right, actually.
Yeah, it was just very close. I was wondering if the screen monitor the behavior or the vulnerability.
So screen is looking for behaviors, not for vulnerabilities. In fact, we don't really know much about, and deliberately so, about, for example, whether you put a double equals or a raw in your ERB code, for example. What we're looking for are the results of attacks, right? So we can tell you if something has been exploited, and we can tell you where in your code that was exploited, but the idea is that by being very flexible about what we're looking for, by looking for the end result of an attack, then we don't have to worry about fixating on known vulnerabilities. We can adapt to new vulnerabilities as they arise.
And just like a second question, I see that like on the gems, there's a lot of screen typos that are not protected, that are not covered. How do you protect the gem from typo attacks?
From typo attacks? Oh yeah, that's a good question.
Just name squat?
That's something actually that we're working on. So we can't, at the moment, it's true, we can't protect you against that, right? So if you install, for example, right now it's very difficult to know if you install a legitimate gem that is sending data up somewhere versus like a typo squatting gem that's exfiltrating the sensitive data somewhere. It's very hard to know the difference between these two things, but this is actually one of our focuses at the moment, is understanding like what exfiltration of sensitive data looks like and whether or not we can protect you against that kind of activity. So no, at the moment we can't, except insofar as we can tell you when typo squatting modules have been detected in the wild and CVEs have been announced to tell us about that, then we can inform you that like package X is known to be malicious, right? So at the moment it's not very proactive, unfortunately, no. But it's a very difficult problem to solve. Yeah, that's true. Screen with a Q, there are a lot of typos possible. That's, I see what you're getting at. Okay. That's worth thinking about, actually. Thank you.
I got one question. Do you have, for example, continuous integration protection? I was thinking, for example, you push code on GitHub, it tests the application, and if there is a security issue, it blocks the code. Like test, but for security on screen.
I'm sorry.
What I was wondering is your service, for example, is able to, when I push a code on GitHub, get the hook, and test security issue, run the app and test the things. Oh,
I see. So no, we don't. So if you want to do something like that, there are a number of very good tools out there. Brakeman is probably the one I would recommend immediately that you use, right? So Brakeman is a tool that has a GitHub hook. It gets called whenever you push something up to GitHub, and it performs a static analysis of your code, right? So it's familiar with existing patterns that suggest that there's a vulnerability in them. And it will help you identify 75 to 80% of the vulnerabilities in your code. It's quite good. I actually do recommend it. But Screen is actually something different. So it's something that sits in the runtime environment. It doesn't look at your code directly, but again, it's watching users' behavior to see if they're capable of escaping the privileges that they've been given explicitly by the code. Does that make sense? So the two things are meant to be complementary to each other.
Perfectly.
And just in the same way, so you're more about the prevention. Is there just a kind of reference website where you put the URL and it tests the SQL injection, it tests the JavaScript, it tests all the, let us say, the classic attacks, and gives you, a kind of a red or a green flag on it? Does that exist, or is there something that you recommend to just test a URL?
Yeah, no, that's a good question. Well, you can always download SQL Map and look for SQL injections with that. There's another automated tool. It's much harder to use, but it's very, very powerful, called Arachne. All right, Arachni, Arachne. Very popular with the script kiddies, but popular because it's very, very powerful. And it's designed to crawl through your website and look for cross-site scripting and SQL injection vulnerabilities. Screen itself, we don't offer a tool for this kind of behavior, but in fact, the two things can work very closely in conjunction with each other. In fact, we also recommend hiring professional pen testers because pen testers are going to be much more sensitive to the context of your application, to the tech stack that you're using, and they can focus their activities on finding quickly vulnerabilities that might exist in your app, right? Rather than relying on automated algorithms like Arachne. So these tools in conjunction within Screen on the back end, you don't even have to put it in production, even in just staging, right? Can tell you quite a lot about the vulnerabilities existing in your code, right? Between Arachne, SQL Map, and these people, pen testers exercising your code looking for bugs, and then Screen detecting when bugs have been found and telling you where those bugs exist in your code. Like, we believe that's a very powerful combination for stressing your application. But even if you don't want to use Screen, like Arachne, SQL Map, super cool tools. It's worth taking a couple of days to sit down and understanding how they work, just to see what they can tell you about your own web application.
There is a tool by OWASP that is doing that, scanning the application and testing all of the main security vulnerabilities. I used it 4 years ago. I don't remember the name, but it's built by OWASP.
Okay, that's good to know. I wasn't familiar with this. If you haven't heard of OWASP, I'm sorry? Oh no, I don't know this tool, I'm very sorry to say. OWASP is an organization dedicated to basically thinking about web application vulnerabilities, classifying vulnerabilities, and educating people about these kinds of vulnerabilities that might exist in your code. They have a huge number of resources. I didn't know that they had something like this. That's very cool. And I strongly recommend a visit to their website and their wiki for learning more about these kinds of things. They have a deliberately vulnerable application called Web Goats that our Web Cows is loosely based on. Something about ranking farmyard animals. But it's designed as sort of a pen test training utility. So if this is the sort of thing that interests you beyond using automated tools, it's really cool, actually. You can install it in your system, run it in a Docker environment, and it will actually guide you through the process of exploiting itself. It's a little meta in that regard, but very cool and a lot of fun if you want to learn how to think like a hacker, how to think like somebody who wants to attack a web application. So basically the OWASP organization, I recommend everything that they do, in fact. No more questions? Oh.
How do you keep up to date with like all the latest security vulnerabilities in applications and the web?
How do we at Screen, or how do you in general?
You at Screen, like you.
That's our job. There are a number of very good news feeds. There's a number of critical vulnerability, I don't remember what the E stands for, CVEs, that come out through a variety of channels, and we simply, we read them each morning. And then we try to distill what information we can into our product itself as far as possible. As far as resources that might be useful to you directly, I don't have a URL off the top of my head, but I'd be happy to share that with you afterwards.
We are very happy users of Screen. We mind, but unfortunately we have only the minor type of scanners only. We don't have big security problem that you have saved so far. Do you have anecdotes, public anecdotes of serious threats that that you have blocked that you could share?
Serious anecdotes of things that we've blocked that I can share. Let me try to anonymize a little bit at screen. I also have Slack stories I can tell. No, wait, I'm sorry. I don't have any Slack stories that I can tell. Okay, so we had one client, a very big client. Everybody in the room has heard of them. I'm not going to say their name. They were very on the fence about our product. It wasn't obvious to them that it was something that was very useful to them. They'd been running it for some weeks. They had only seen a handful of script kiddies running automated scanners like Arachne against their website, blah, blah, blah. This happens every day to a large website, no big deal. And so they assumed that everything was fine, and they were about to, in fact, just let the trial expire and not move on. And then one day, one of their users signed up for their website, and they had an apostrophe in their name. And that apostrophe was enough to escape the SQL statement that went and inserted their name into a row and actually created an SQL injection. Right? Like, so normally it would have just thrown a 500 and people would have been like, well, why did this throw a 500? I don't know. You know, there's some bug somewhere, we'll track it down later. But what in fact that user had discovered was that through the use of a single apostrophe, they had found a way to escape themselves out and could theoretically, if their name hadn't been something like O'Reilly, appended additional SQL onto that to gain access to the entire database. And well, you saw the results of that. Within an hour, they were a paying customer. That was very nice. Not a super compelling story for y'all. It was very compelling for us. We broke open a bottle of champagne and whatever. Aside from that kind of story, it's hard to say exactly. Oh, but you have a question.
Do you attack clients or prospects to make them sign up?
Yeah, in fact, we've been hammering Microsoft servers for the last year continuously. No, we don't do anything like that. So we do have a couple of security scanners that we offer as a service for anybody in the community, however, that does a very, very light assessment of the security of a website, largely looking at the HTTP headers that are being emitted, and anything that we can glean from those that suggests that there's a vulnerability open to it. And we provide that for the community's information, but no, God, that would be really kind of shitty. Hey, we found an SQL injection in your website. We logged in the other day just to verify it using your admin account. No, we can't do that. That would be bad. We're white hats, not black hats.
I have a question regarding the brute force attacks that you mentioned.
Yeah.
With device, for example, when we try 3 passwords, the account is locked. So is it not a miss, the brute force attack? Is not once you've stolen the whole database that you can do a brute force attack? And another question, is there a way to, are there good practice to model a database to obfuscate the data once the database is stolen, or to prevent maybe to decode the data, maybe encode, but I think if it's encoded, it can be decoded easily, so I'm not sure.
Yeah. Actually, I have some very strong recommendations for that. Devise, yes, does help block brute force attacks by keeping track of how many times you've tried to log in, and that's very good stuff. If you're not using Devise, but something of your own, you may not be keeping track of that. There are plenty of other systems for authentication in other languages that don't keep track of that, and that's pretty unfortunate. So, like I said, we're big fans of Devise. Like, they get a lot right in terms of authentication, and so we unabashedly recommend using Devise, building a Rails app. As for your database itself, obfuscating the contents. there's not a lot that you can do. Did anybody see today's commit strip? Does anybody here read commit strip? Yeah? So today's commit strip was like, what if we encrypt the entire database, right? So only the clients can gain access to it. I'm like, okay, that seems like a good idea, except like now we can't do anything like look at the data at all, which is exactly why the database exists. It exists for us to look at the data and do things with it. And so it would break all of the functionality in our web application, full stop. So there's probably not much you can do to obfuscate the data inside of it, but there's a hell of a lot that you can do for the password field, which is arguably like the most important piece of data in there, and ironically is the one you need least access to. And so there's three things that you should do when you're thinking about obfuscating the password. And the first is, and Devise will take care of a lot of this for you. If you're using Rails, use Devise. If you're not using Devise, hash the password with a cryptographically strong hash like bcrypt, right? So the idea behind a cryptographically strong hash, well, let me start over for a moment. When you log into a website, right, and you give your password, the idea is you don't just compare the password directly with what's in the database. That would be terrible, because if the database got out, then everybody's password got out as well. And so you run a cryptographic hash on it. And the idea is you only store the hash results. Person types in a password, you hash it, and then you compare the hashes, right? And if the hash is matched, then the passwords must match, and that's fine. The idea behind a cryptographically sound hash is it's a hash that takes a lot of time, right? To slow down brute force attacks, right? Ideally, it should take more time the more times you try to use it. And so bcrypt is a hash, for example, where you can say, I want it to be exactly this difficult to compute this hash. And that number can go up as high as you want it to, right? It can go from, I want it to take a millisecond using today's computing technology to, I want it to take 10 years using today's computing technology. I don't recommend that setting, by the way. But even if you just hash it, that's not enough. Because if somebody gets the full database with all the hashes, then even with a very cryptographically strong hash, they can run something that's called a rainbow table attack. And I love that name, but I don't know how it works. But the idea is when you have all the hashes, you have enough information to compute how the hash function works, and then you can begin to tear it apart, right? And so the next recommendation is you can beat this by using something called a salt. And so a salt is something you add to the password. So I type in my password, your salt might be just a string, right? It might just be the string salt. I don't recommend that as your salt, but you could use that as your salt. So you take my password, append salt to it, then you hash that, right? It makes it much, much harder to run a rainbow table attack against the database entry if they get all of it. Because it essentially takes the password and it obfuscates it with a little bit more information. So that's one step that you can take, is to salt the passwords. The next step that you can take is you can also pepper the passwords. I'm not making this up, right? So pepper is a salt that, so use the same salt for all the passwords and then use a different pepper for each password, right? So you take the password, you add the salt, the same thing that you add all the passwords, and you add the pepper, right, which is specific to that password. And it doesn't even matter if they know what the pepper is, right? It doesn't matter if they know what the salt is. By adding these things onto this, it makes the hash computation that much more difficult for them to compute. So my best recommendation for maintaining your database is use bcrypt, or there's a couple of alternatives that are even stronger whose names escape me off the top of my head. Salt the passwords and pepper the passwords. That's about as good as it gets. Beyond that, it's kind of up to you, but that's the important bits right there.
I actually have a story of hacking. I don't know if somebody asked.
Oh, can we get a microphone for him?
So somebody asked about the hacking. So what I'm doing is creating a music encyclopedia. I was on tests, so I had like 2 users. really 2 users, and so I have a dedicated server on OVH, and one day they just shut me down, saying that I had something like 40 terabytes of data going out, and that I had exploded their bandwidth, so they had to shut my server down. The point was just, I discovered much later that I was using an old version of Elasticsearch, which had a flood in it, and that it could be exploited to create DDoS. And that's what was done. And that's why now I know that I have to update my Elasticsearch server. And that's why I know that I have to watch my logs. And that's why I know now that every day, all days, I have requests like zikme.org, which is my server, /admin.php with escaped strings all the time. Sometimes different, sometimes from Russia, sometimes from China. Just guess what they are trying to do. Even if my app is in Rails, so it doesn't matter, they always try PHP stuff.
Mm-hmm. Yeah, that's a good point. Actually, in fact, an attacker's first guess, if they encounter your website, the first guess is, let's pretend this is a WordPress installation.
With PHP myadmin, stuff like this.
Oh yeah.
They try it all the way. Like they have scripts and they go at like this. That's it.
Yeah. Yep. And they're just looking for vulnerable PHP endpoints. Oh, PHP. And that actually led to a denial of service attack because they were spending so much time.
This one still happens. So I think like almost every day I have a request like this on my server, but I'm on Rails, so it's okay. I don't mind. And now my Elasticsearch is up to date, so I don't get hacked, but my Elasticsearch was hacked.
Cool. Thank you. Well, okay. Cool for the moment here. Not so cool for you. We had one more question over here, I think. What's that? Oh.
Me, I got a question. When you said we should back up the backup, what service do you use and how do you do that?
So there's a lot of possibilities here. I recommended specifically, and there's lots of options. These are just ones that came to the top of my mind. Amazon S3 and Tarsnap. Amazon S3, of course, is just like generic storage for stuff, right? Tarsnap is actually a service specifically for backing up data and storing backups in long-term service. So the bandwidth is quite low, but the storage capacity is quite high. And you're actually charged, I think, by the bandwidth rather than what you're storing. The name itself is an interesting and funny story I can talk about later. But the idea is have at least 2 backup strategies in mind, right? Don't put all of your eggs in one basket. Figure out 2 different things that you can do to keep your data backed up. And on top of that, actually try restoring from backup periodically, right? So there's another story in this line, right? So GitLab, was it 6 months ago, right? Like they kept meticulous backups of everything, but it turns out that their backup procedures were shit. And they were not able to actually recover from backups. And so point being, it's not just that you have things backed up, but that you also have procedures that will allow you to successfully restore from a backup as well. S3, Tarsnap, they're both very good. I'm trying to think of anything else off the top of my head that comes to mind. Honestly, that's all I can think of. I mean, hell, physical hard drives, right? Like, never underestimate the bandwidth of a station wagon full of magnetic tape. There are options. If anybody else is using something different than those, feel free to jump in and save me here because I'm flailing. Anyway, those are quite good. Oh no.
Yeah, much better. At Le Wagon, we learn a lot with, we work a lot with Heroku. Is it something that is trustworthy? What is your opinion about the service? Is it top-notch security or some vulnerability that you might share with us?
No vulnerabilities in Heroku that I'm aware of, aside from what might exist in your own web application. No, I think Heroku is perfectly fine. Heroku, DigitalOcean, Amazon Web Services, Google, whatever they're calling it these days. I swear to God, they've changed the name of it 5 times in the last 2 years. I don't know. No, I don't think there's anything wrong with these. In fact, quite the opposite. All of these services have dedicated security teams that are thinking day and night about the security of their service for their customers, and I would trust them implicitly. I mean, even locally, like, you know, Platform.sh, Clever Cloud, companies like that. Yeah, like I wouldn't use any of these without hesitation. I would use any of these without hesitation. Yeah. Oh, we got one more here in the front.
If we have 5 minutes, like I have my own story of using AWS and got. Like you talked earlier about stupid people leaking the AWS key, and it happened that I was one of these stupid people. I got my key leaked like that, so I was just starting to learn Ruby and Rails. And I did a little app just like you, and people could upload pictures. And I needed a storage for these pictures, so I chose the AWS because it happened that it was good. And I did a series of mistakes that happened, like, could have ended, like, it ended very badly, but it could have been worse. Well, first mistake, I used my general token AWS, like the token that allows users to do everything. Because I was too lazy to read the small prints in AWS, like I come to AWS for the free offer. You have like 1 year free if you don't exceed what they, like the things they give you. Like you just use the basic pack. It's free for 1 year. Okay. So I'm like, okay, sure, it will be free, no matter. I take the token, I hard code it into my Rails app, which is like another mistake. Don't do that at home. Then I'm so proud of what I just did that yet another mistake. I push it on GitHub, which is like the biggest mistake of them all. Third mistake, well, I had used for my AWS, I had used my login was my email, but it was an email I wasn't checking a lot because I was like, yeah, they were going to spam me, so I'll just use this email I don't use. So I pushed this on GitHub, and then yet another mistake, I got in vacations, and I don't check my mails for like 2 weeks. I come back after 2 weeks, I log on my mail, I see literally 20 mails from Amazon, like, your account is compromised, please do something. I'm like, oh shit, what happened? I log on to Amazon Web Service. I checked my dashboard. They're like, you owe us $15,000. I was broke. I was like, okay. So what happened? Well, as Don said, it didn't take 1 hour before a bot came into GitHub, took my AWS keys, and started renting shit tons of servers to mine Bitcoin on my bills. Well, so, you know, successions of small mistakes and one big that led to this happening. In the end, I didn't end up paying the $15,000 because Amazon, apparently it happens to them a lot. I'm not the only stupid guy who did that, apparently. But yeah, like, once this happens to you, you start paying real attention to these kind of things. So yeah, don't do anything that I did this day. Thank you.
Nice. Thank you for sharing. Bitcoin mining is like, it costs a lot of money, right? 15,000 euros. Holy crap. It costs a lot of money. But you know, the worst scenario, in fact, is when they launch a very small server that costs you an additional like 50 cents a month that you aren't paying attention to, but that server is monitoring everything else that all of your other servers are doing and reporting it somewhere else, right? And it's much harder to detect. Nice, thank you. Huh? Well, y'all, thank you so much for your evening. I'm glad that you came out to hear this. I'm happy to talk more about this in person. That's my Twitter handle. If you have security questions, please feel free to ping me. I'm happy to talk about anything security related, anything that I can do to help you build a more secure web application. I'm at your disposal. Thank you so much.